welcome Titus from many of you know Jinko for their solar panels, and a growing number of you start knowing Jinko for their storage solutions. And Titus is here today to tell us a little bit more about those. For those of you, probably just a few who don't know Titus yet, Titus is the technical services manager at Jinko. He's been in the industry for 10 years now. Every year when you join, I add one number to your years of experience, Titus. Yeah, you've been working with several key players in the Kenyan solar space, Solar Gen, Africa Solar Design, Solar Kiosk Solutions. More recently, so with Jinko. And especially, and this is also why you're here with us today, you've been managing several very interesting projects, including PV, diesel, and energy storage. So it's great to have you with us today. So you can tell us a little bit more about those solutions developed by Jinko, and also a little bit about the projects you've been working on. Titus, over to you.
Thank you so much, John. I think you've actually said a lot, and I don't think I'm going to introduce myself anymore. And let me also say thank you to all the panelists that is from the previous session, and also all the attendees who managed to take their time to join in today for this very interesting conference. Since you've actually introduced myself, you've introduced me, I'm actually now going to go straight to introduce Jinko and also the topic that we are going to handle in today, that is on innovations, that is ideally for large-scale energy storage. And Jinko is actually, I think there is almost, let me say, 80% of the participants know about Jinko is as being a PV module manufacturer since 2006, and also been one of the leading manufacturers in terms of module shipments, R&D. And also a few years ago, we actually went into energy storage as a solution provider as well. That is in all the segments, that is for residential, commercial and industrial, and also utility as well. And of course, with different product ranges. As you can see from my screen, there is from the Suntang, that is Sun Giga, and also most recently the Sunterra, that is ideally for utility scale applications. And as just to also recap, and also there was very good introduction from Felipe from CB before, that is with regards to the energy storage situation in the region. And I would like to just recap and say that there've been developments in, or rather demand for energy storage. And I think globally, having a global outlook is that US, of course, there is more demand from the US side, and of course, followed by China, EU, and followed by the rest of the regions, including mostly developing regions, including Africa, and of course, with more demand on the FTMs, and then followed by ideally the BTMs, that is behind the meter, that is storage solutions, majorly for residential and commercial and industrial. This is basically based on the studies conducted by research institutions like the likes of IHS, that is giving projections for the growth and of course the energy situation, especially for energy storage globally. And what you can say is that with more focus into sub-Saharan Africa and let me say Africa at large, is that they've been ideally need to go to, or rather to invest into energy storage. And what is estimated currently, like for likes of IHS and also from Bloomberg as well, expected like approximately 1.6 gigawatt of energy storage is currently installed. But this is mostly from pumped hydro, which actually accounts for almost 80%. And we are looking at LFP, that is lithium iron phosphate, that is also gaining in some bit of market share because of the cost attractiveness and also the modularity of the technology. And but of course, that the main thing about the slow intake of energy storage is mainly because of some few barriers. We actually call them challenges, which includes one is capital intensive, that is the cost. Looking also into the other aspects, technological, that is the technical expertise, that is minimal technical expertise available in the region. Also looking at the economic stability in the region, you would find that most of the economies in Africa would actually focus only into stabilizing the economy and not really investing so much into power or rather their grid. Also looking at the very poor grid infrastructure as well, which I think also in the other side, or rather in the flip side, there is also motivation for energy storage as well, as energy storage comes in to also boost on the grid infrastructure as well. Then this being the challenges, we've also classified as an OEM, we've also classified our own challenges that we see. And of course, it's also the basis of that is our R&D process. That is one, we've classified the main challenges into investing into energy storage solutions as there is three main categories. One is basically on the capital expenditure, that is the CapEx. We're also looking at the OpEx as well. And also safety. You know, safety is something that we highly take into account, because knowing the fact that battery or rather energy storage solutions are capital intensive, so ideally needs high levels of safety. I know, I think for the last 2 or 3 years, we've actually witnessed close to there is three main accidents from fires that is occurrence in energy storage projects. I think mostly in I think two in US, California and Arizona, and also in Australia as well. We've not really witnessed anything so much that is in Africa, but of course we come in as an OEM. We try to be proactive to mitigate that. So this is basically, I can say that this is the basis of our R&D process, that is the CapEx, OpEx, and also the safety optimization of all our solutions. And just to give you an overview of what we've done and with regards to the solutions that we provide as an OEM, is that we've actually classified that is for when now addressing that is large scale ESS, we've classified them under that is C&I, where we have the Sun Giga solutions, and also the utility scale applications as well, where we have the Sun Terra solutions. So for the Sun Giga, where we actually play in the C&I segment, we have the microgrid solutions, which is usually small size, that is from 69 kilowatt-hours to 1.6 megawatt-hours. And also most recently, we also launched, that is the liquid cooled solutions, that is based on only technologies for the liquid cooled, that is mostly the battery cabinets between 250 kilowatt-hours and also the 340 kilowatt-hours. The reason why we introduced these liquid cooling solutions is because we wanted to also enhance the safety, or rather the fire safety of our equipment, or rather battery energy storage solutions. That is one, and also to also address the issue of the scalability of our solutions, that is into megawatt scale, let me say 20 megawatts, 30 megawatts, which also sometimes plays in the same segment as well. And also, we actually, I think last year, we announced this utility scale application, or other energy storage solutions, that is battery containers of 344, that is 3.44 megawatt hours, that is in a single 50-foot container. That is actually the highest energy density among the highest, not the highest, among the highest energy densities that we have in currently the market. And also it gives us flexibilities to also build up into hundreds of megawatt hours. I will still explain that around and show you some solutions that we're building that is up to 500 megawatt hours in especially in Middle East and also in China region as well. And for all the solutions that we build, is that we build based on the lithium iron phosphate, that is the cell chemistry. The reasons being, one, I think that was mentioned in the panel before, is focusing mostly on the energy density, the power density, the cost, and also the cycle life as well that we're looking at. So just to give you a recap, is I will not focus so much on this Sun Giga solutions, but I will give you an overview of the Sun Giga that we actually deploying. We've deployed a number in the regions, that is actually in all the sub-regions of Sub-Saharan Africa, that is East Africa, West Africa, and also Southern Africa region as well. And with this, basically, we have battery containers, so that is with all the components pre-wired, pre-assembled, and also pre-configured in the container. That is with the major components. That is one, the batteries with the BMS, and also the inverters. That is 50 kilowatts to 500 kilowatts, and also batteries clusters. That is from 6.9 kilowatt hours all the way to 1.6 megawatt hours. And also, we've also integrated with there is the energy management system that is actually included in the containers. And to also enhance the safety, we've also included fire safety, that is automatic fire extinguishing equipment, and also thermal control system as well. That is the temperature control system. That is basically the HVAC based on air cooling. And of course, we made it in such a way that we can be able to also integrate other energy sources. That is, of course, our main focus was mainly on renewables, but of course, we can also still integrate diesel generators and also utility grid as well to be able to charge in the batteries. And currently, we limited to less than 2 megawatt hours in a single block of 140-foot containers, but being able to parallel up to 4 units of 40-foot containers. That makes it around 2 megawatts and 6.4 megawatt hours. And looking at the layout is basically what we're trying to address. That is the challenges, especially with the technical expertise in the region. And we've solved this by having all the components that is pre-installed in the container. You can see the container being split into two parts or other compartments. That is the batteries and also the power conversion equipment on the right-hand side as well. And looking at the lifetime of what we're looking at for these solutions is that we're actually looking at close to 5,000 cycles. That translates to almost 15 years that is calendar life, assuming, let's say, 1 cycle per day. And also is that there is actually this solution for the liquid cooling, which we introduced that last year. So this liquid cooling was specifically designed for our utility scale battery storage solutions, but owing to the demand, we've also integrated this in our C&I solutions by having in battery cabinets. Of course, battery cabinets with one liquid cooling plate, that is battery pack, the liquid cooling plates, and also the liquid cooling unit as well, and also the high voltage box, that is for the termination of all the battery things as well. And of course, we've also integrated there is fire suppression system and also explosion proof design as well. So that is basically part of it. But for regards to the liquid cooling concept, so we are going to look at it in the next few slides to discuss more on how this liquid cooling technology is actually applied and how it also contributes to the three main issues that we discussed before. And currently is that with these solutions, we're actually looking at 215 kilowatt hours as standard. That is low voltage range. Low voltage range that is ideally between 672 to around 864 volts, and also the high voltage range that is more than 1,000 volts. That is for 344 kilowatt hours. The advantage is that we're also looking at, like I said, we're trying to address the issue of scalability of our solutions to more than 6 megawatt hours with this liquid cooling cabinet, and also the flexibility. And also the other thing that we're also trying to look into is also being able to integrate, that is, to other PCS brands as well. That is not only Jinko PCS, but also being applicable to other PCS brands as well. And you can see with such kind of scenarios where we have in the battery cabinet, there is all parallels to achieve the required battery capacities in mostly megawatt hours, and also looking at the PCS station, which can either be Jinko's PCS or can also be any other PCS brand. I'm going to demonstrate in the next few slides, and also looking at for this scenario, for the DC coupled scenario, where we have can also supply with the DC converters as well, where we can actually connect the PV modules and be able to build up the whole power plant. And that thing is that you can see from the current scenario that we're looking at, that is from one of the battery cabinets, either 215 kilowatt hours or 344 kilowatt hours, that is the master battery cabinet. Then we can also add in other slaves as well. There is other slaves of either 215 or 344 based on the voltage range that is required, rather the input voltage range of the PCS. And of course, we can build up to 10 units, that is up to 10 units, that is one PCS. So with, let's say, 10 PCS, then that means that we can add up to 100 units. 100 units. So that means almost to less around 20 megawatt hours or 30 megawatt hours, depending on the voltage as well. And you can see also that what we also tested is basically compatibility with our own in-house PCS brands and also other OEMs as well, including EGTeam, SMA Electronics, and also Huawei as well. And we also, you see that we are also trying to have this flexibility where we can actually couple with any of the PCS brands that is also available in the market. And looking at also, I wanted to explain the concept of liquid cooling. Why is it really an innovative solution? And also that is what we require, especially for large-scale energy storage. So liquid cooling technology is basically a technology where we have, instead of normal air cooling, where we have the air conditioning, so we actually have been coolant, which in this case, what we're using now is basically a mixture of glycol and water. That is 50% glycol and 50% water that is flowing directly on each of the battery packs having cooling plates. You can see indirectly on the liquid. So what the end result is that we actually going to have uniform, there is uniform temperatures in the container. To be in perspective, or rather to be specific, for the small 1 giga liquid cabinet, that is the 215 kilowatt and the 344 kilowatt, the temperature difference is actually less than 2 degrees. And also for the battery containers, that is the 24 battery containers, we're actually looking at the temperature difference of less than 2.5 degrees Celsius. And what we've actually as the basis for our Sunterra, that is energy storage solutions, or other utility scale energy storage solution, is basically we base this on one, like I mentioned, based on lithium iron phosphate because of the reasons that I did mention, and working with battery cells of 280 Ah. We're also looking at currently maybe slightly higher battery cell capacities as well. So that will be discussed and also will be publicly announced maybe in the next few months or so. Then we're looking at one standard of 20-foot containers, and currently we've actually standardized at 3.44 megawatt in these 20-foot containers. And the thing is that we can also be able to scale up to any capacity, so there is no upper limit. Actually parallel, so ideally we can achieve the highest megawatt hour or other projects in the region. And of course, also like our main focus with this Sunterra is mainly focused on one, the safety, the air safety. We're also looking at the air's energy density as well. I'll still mention about this as well. We're also looking at the efficiency, that is the charging efficiency, the round trip efficiency as well. And also looking at lowering the power consumption, especially that looking at working with air cooling. We add with air cooling as well. So we're making that challenge, and also the lifetime of, or rather the service life of the storage that we're looking at, because right now we actually give warranties of up to more than 15 years as well. And also the on-time cost, that is usually very much aspect that actually affects the cost of energy. So one, like I said, is that the three main things that we focus, or rather we think is actually very important, especially for energy storage and battery storage to be specific. That is, one is safety. So we've in our solutions that we decide that is the highest level of safety. So are we going to ensure this that we achieve these safety levels that is actually required? So one is that we're looking at there is 5-layered safety level protection. That is from the cell level to the module level. Each of the packs is in 5, that is adding 4 modules. So having in protection from the cell level, of course, with layer P technology, and also robust battery management system that is usually 3-layered. From in-house layer, we can actually monitor up to the cell level, then also having protection on the module level as well, and also protection also on the pack level as well, with heating codes as well, to prevent ideally thermal runaway. And also, we've also integrated that is optional fire separation system. Should you want to having, let me say, jet, that is water jet as well on the pack level as well. That is also an option where you can integrate that is fire separation system up to the pack level. Then also looking at the rack level as well, there is advanced cluster management system and also inflation detection, and also separated racks as well. And looking finally at also the system level, that is basically the higher level where we have the gas separation system, and also optional water fire separation system, which actually comes in if the gas fire separation system, or rather the FSS, is not able to address the current fire concerns, and also having in explosion-proof containers as well. So with regards to the system level, we're actually looking at the advanced fire separation system, where we have a number of sensors in the container. And of course, our fire separation system is actually compliant with international standards. That is ideally from NFPA, that is the National Fire Protection Association standard as well. And of course, we have a number of flammable gas detection sensors in the containers, and also we have this. You can see there's different levels of sensors in the containers to be able to detect any thermal runaway or any gases on the different points of the containers. That is the 10-foot container. And also as well, that is for the fire separation system, we also have the smoke sensor as well. That is actually two-way, that is having in smoke sensors and also the temperature sensor as well. Should there be any abnormal temperatures in the container as well, can be able to activate, that is the fire separation system, which can actually be triggered either manually, or it can also be done automatically as well. Then we've also employed, that is one, that is artificial intelligence, that is AI, to be able to check, or rather to assist, especially for on them, that is be able to do inspections up to the cell levels, and also any abnormal operation role up to the cell level can actually be reported into the monitoring system, and it will lessen our on-them time as well. And it also enable us to do early detection as well, prevent any instances of then I think as well is that we've also employed, that is mica sheets, that is usually between the battery cells, to be able to prevent thermal runaway from one battery cell to the other battery cell as well. That is basically to also ensure the extra level of protection. Then the other thing is that also on the back level is that we also have insulating sheets as well. Is that of course with very high temperature resistance, that is actually more than 1,300 Celsius. So to ideally prevent provocation of flame or even increased temperatures from one of the packs to the next, that is to the adjacent packs. And this just to show that is on the deflagrating system, that is basically the explosion-proof system. Should there be any incidents of flammable gas or maybe high pressure in the containers, it actually has an automatic system that will actually open the ventilation system to be able to release the accumulated pressure in the container. And the second aspect, that is one, that is basically the center of focus for our utility scale energy storage, or rather the Santara system, is focusing mostly into lowering the LCOE. So there are three main ways which we've actually optimized to lower the level of energy. One is the energy densities in the containers, looking at maybe standard liquid cooling containers in the container that is in the markets. That is 40-foot container, 20-foot containers, sorry, not 30-foot containers. We're actually looking at close to 2.8 megawatt hours, that is, of energy storage in one container. But of course, with the Santera, we are looking at close to 3.44, and maybe also in the near future, we are actually adding more than 3.44 to be able to optimize on the megawatt hour per container. And of course, to be able to see, of course, for smaller projects, let's say less than 10 megawatts, it might not be significant as well. But looking at large scale projects, let's say for this case of an 100 megawatt hour projects, with the difference in energy density, of course, with the traditional energy storage systems, because we're looking at close to 37 containers, whereas with the Santera system, the 3.44 megawatt hours, we're actually looking at close to 30 containers. So looking at this perspective in terms of shipping costs and also the project area that is required, that is the land area required. So we are having that savings as well. And the other thing as well is that what we've also, because of the optimized temperature control in the containers, is that we can actually, it also allows in side-by-side layering or the placement of the containers. In that, ideally for traditional containers, it actually required that you have some, that is some spacing close to 1.5 to 3 meters, that is between one container and the next container. But for the Santera, that is for our Santera solutions, we can actually have in side-by-side placement of the containers. So ideally, if looking at, let's say the same 100 megawatt projects, so that means it's also optimal, rather reduced size of area that is also required as well. And because also, like I did mention, there is actually optimized temperature control and the temperature difference in the whole that is container from one part to the next part. That is the high temperature in the whole container comparing to the lowest temperature is actually under 2.5 degrees Celsius, because this uniform heat distribution actually leads to more of increased service life by more than 10%. And that's why we actually able to guarantee that is up to 15 years, that is 15 years calendar life, that is actually guaranteed. Or also we can also do 7,000 cycles at 90% DOD and 0.5 C. So we can do this 15 years or also 7,000 cycles, whichever comes in first. And also there is also cluster management. There is automatic cluster management technology that we've actually employed. That is smart in nature, in that any battery cluster that is fully charged drops out and the rest continues to charge. So ideally the end result is that the end of it all is that all the battery clusters will be charged to 100% as compared to conventional cluster management systems. Of course, with without smart cluster management system, where we can have in once one battery cluster is actually 100% charged, the rest will also stop in charging. So ideally there is an uniform charging and ideally lower round trip efficiency. So what we are talking about in terms of numbers is that we're actually looking at around 92%, ideally more than 90%, that is round trip efficiency. And also is that because of the liquid cooling mechanism is that there is one reduced energy consumption, that there is no need for high power, that is cooling or rather HVAC units as well. And of course we have very good thermal conductivity for that is the cooling agent that we're using, that is rather for the coolant, that is a mixture of water and coolant compared to the thermal conductivity of air that is close to there is the difference of around 1.5%. And the last aspect is basically on the on-demand as well. And what we've done is that, of course, we try to spend more time that is at the factory to do pre-wiring and also assembling and also the configuration of the whole system. That is basically to reduce the on-site installation time. Depending, looking at, let's say, one container, then that would basically mean that we are looking at close to maybe 1 day that is installation time. And of course, this is basically going to reduce that is on the overall cost of the whole project. Then also looking at the other aspect of on them as well, we looking at the aspect of cluster management, looking at the aspect of that is SOC calibration. You don't have to do any manual SOC calibration because it's actually automatic calibration as well. Then because we're also using a cooling agent as well, of course, every container required close to 450 liters of the mixture of glycol and water, that is the coolant. So replenishing this, let's say manually, would require, there is a lot of manpower. So we've actually made this automatic, so you don't have to do it yourself. That is on site. Then, of course, as well, is that the SOC calibration is actually, you don't have to do, like I mentioned, not manual calibration, it's automatic calibration. And it also allows, that is the cell technology, that is the calibration technology, automatic calibration technology allows for, that is bidirectional flow, that is between the battery cells. That is from one battery cell to the next. So you can actually allow for bidirectional energy flow as well. And of course, we've also, that is integrated, that is apart from the EMS, we also have been a monitoring system that is specifically made for the battery containers, where you can also be able to access for online inspection checks and also for purposes of O&M to check in case of any leakages, to be able to check on also the battery cells, should there be any should there be any defects in any of the battery packs or also the battery cells as well. And finally, I think this is just to show you some of the projects that we currently deploying. That is close to 500 megawatt in the Middle East. That is done in 2 phases of 300 megawatt and 200 megawatt. That is by the end of this year. This is currently in production. We've also had a number of projects, including this, that is 20 megawatts in China, mostly for peak shaving and frequency regulation as well. So you can see all the battery containers and the TCS and also the MV stations as well. And also a number, that is, we have a number of these 1 megawatt to 2 megawatt projects, especially in the region, of course, including this, that is 1.1 megawatt for actually a mining grid in northern part of Kenya. So I'll end in at that point. Maybe I'll take in some few questions. Back to John. Maybe if there's a few questions from any of the attendees.
I need just 1 minute to breathe. That was the most powerful presentation I've seen in a long time. Lots of information, Titus. Thank you very much. I think people will need some time to absorb it. And on this point specifically, we've received a question several times. Will the presentations be shared? Yes, of course they will. So you will get ample time to go through this very information dense presentation by Titus, and of course get a chance to follow up with him directly. It was Titus, it was a little bit longer than I had planned, so I need to be a little bit shorter than I would love to on the Q&A. Because we were talking about quite technical aspects, I would like to continue in this trend before we move on to a pure financing topic in the next session. I would like to ask a question from Stefan. What is your experience with inverter/power conversion reliability in BESS solutions? Many BESS projects rely on uptime. Are there credible and scalable inverter solutions for hybrid and AC coupled systems with secure uptime?
Yeah, I think that is actually a very good question, because PCS would actually forms close to 40% of the old BSS, that is batteries and the main components. So we're looking at talking in from our experience is that we have PCS that is usually scalable, that is from 50 kilowatts all the way to 500 kilowatts, and can also be able to extend to megawatts. That is, I'm actually looking at the small microgrid solutions. And in this case, even for the 500 kilowatts, is that what we've actually made in we've made in modular, that is in modules of 50 kilowatts. In that, should there be of course, any faults in the PCS, you're not losing the whole 500 kilowatts. You can actually be able to isolate, that is part of the plants, to be able to organize maybe for replacement or repair as well. So that is one of the things that we're looking at. So the thing is that reliability is very important, but it also needs to look for ways of maybe mitigating should that happen, there is any of those failures happening. So, but so far, I think for the last few, that is for the last almost 2-3 years that we've had in our experience, we've had some few challenges, of course, different project requirements, of course, with different customers. The project requirements usually vary. Sometimes the project requirements are also not correct, and we've had to make some few changes. So you can see you need basically to having the bit of flexibility in your design, and of course the modularity is very important.
Thank you very much. Really, I hate to do this. There were many questions about life cycle, depth of discharge. There were some additional questions about the financial aspects of storage solutions, of course. But as always, I'm repeating myself on this, but all your questions will be shared with Titus, so that he and his team will be able to follow up with you. Titus, thank you very much. Really info-dense presentation. I feel we're entering a new era of storage solutions. So this is a very great signal for the work we're all doing. And I'm wishing you a very good rest of the day.